So, yes. Horse? That's not the date. The date is 3/25, brother. Yep, March 25th. So, today we're going to be doing prism or pyramid. Now, these are going to be some three-dimensional shapes. Okay? These are some three-dimensional shapes with which we are going to be working. If I can find where my stylus went. I found it. So represent three-dimensional figures using nets made up of rectangles and triangles, and use the nets to find the surface area of all these figures. Apply these techniques in the context of solving real life and mathematical problems. So to put it into terms that you would actually say, let's see, what you are going to be learning is going to be representing three-dimensional figures in 2D space. 3D figures in 2D space. Now, in that do now, it says, in your own words, explain the difference between 2D and 3D. You may use a visual help to explain to do your explanation, and then I'm going to show you how to do a 3D object pretty easily if you don't know how. So you're going to be writing. Yeah, there's a lot of artistic stuff with mathematics. Well, my desktop background, for one. Nope, that's not it. Let's try to write down a couple ideas. We haven't gone over this yet, so it's okay to be wrong. And then I see a lot of drawings that are happening, which is good. I want you to explain the difference between the drawings, please. You don't have to have a drawing, but a lot of you just have drawings. Just have drawings. Okay. About 1 minute left. You've got some artistic ability in here. All right, can someone share with me and share with the class what you have? What do you have? Right, but how about some words too? Because I can't say that out loud. I'll represent that on the board, but how would you describe that comparing 2D and 3D? Okay, so there's a front and sides. That's a good way to put it. Yeah, if that's for 3D, good. Yeah.
I said for 2D, you can just see the front side, and then for 3D, you can see the side.
Cool. Yeah, that's another way to say it. You can just see a front side for 2D, and that's all there is. Good. Skylar?
In 3D, you can see all sides, like all different angles.
Good. Okay. Good. So I guess we really like the term of having multiple sides in a 3D shape and just two sides, or just one face of 2D. So For those of you that aren't, wow. Sorry. Actually, I could do it. I could do it negative. Let's see here. No. So for those of you that aren't so great at art, okay, here is, obviously this would be, I'm just going to do a parallelogram, okay? So that would be a rough parallelogram. That's just one side. So that would be two-dimensional. Then we could do a 3D object. In order to do that, what you do is you could possibly do a square. Then you do the exact same size square kicked up a little bit to the right. And you just connect the lower left, lower left, or upper left, top right, top right, top right, top right. Then if you really want to make it clear, you can make this the lines that you're not supposed to see necessarily, dots. I can do better than that. I'll do a rectangle. That's not what I want to do. Let's see here. There we go. Gross, but that works. Ugh. So that's not even straight. Yep. So that's another way of describing it. And this one here is something you can actually, I'll do it in dots. Move around to get a different view. That's the general consensus of what the kids were saying. So vocab. A polyhedron, if you can read that, a polyhedron is a 3D object with flat surfaces. A 3D object with flat surfaces. (3D object with flat surfaces, and a rectangular prism has flat surfaces. That's a cube would be a squared prism. And we'll get to that. (3D object with flat surfaces. Then we also have a faces. Flat surfaces. Faces of a prism are rectangles. Faces of a pyramid are triangles. Stop making noises. Flat surfaces, faces of a prism are rectangles. Faces of a pyramid are triangles. See how we got a pyramid on the lower part? I've highlighted the faces orange. See how what I highlighted there is a triangle on the lower one and a rectangle on the upper one, if we were to turn that guy around? Oop. Ooh. Let's see if I can fix that. Yeah. Faces, the base of a 3D figure by which it is measured or classified. Prisms and pyramids are named by their base, not their sides. And if you'd like another review and a different version of this lesson, you can go to my YouTube for last week and see what we did in math for 7th grade. That's right, last week. So I'm going to do the base as red. Ooh. Red. The base is going to be red. There's going to be an overflow here. There. The base is red. Ooh, no. Well, yeah, that would work. Prisms and pyramids are named by their base. This one here has a square base, doesn't it? So what would that one be? What do you think that would be? Just by guessing. It's a pyramid with a square base. No, it's got a square base, and they're identified by the bases. Yeah, Andrew. It has a square base. This pyramid has a square base. What kind of pyramid is it? Yeah, rectangular. Actually, that would be a squared pyramid. A squared pyramid. Okay, a rectangular pyramid would look like this. That's a bad example. That's another square. Let's try that again. There we go. Yes. That's a squared, or a rectangular prism. Rectangular pyramid. Goodness. Skylar.
I can see that triangle in like two different ways.
Yes.
The base is facing this way, or it's facing that way.
Yep. Yeah, I'll show you guys an optical illusion with that in a minute. Then finally we have edges. Side shared by the faces. Side that is shared by the faces, so where the faces meet. So we have an edge. Edges are going to be yellow here. That's where the faces meet. That's where the faces meet. Faces are the sides. Edges are where the sides meet. Do we not get vertexes? Oh, vertexes. Sorry. Yeah, vertices. Vertices are the point at which these edges meet. That's correct English. The point at which these edges meet. Thought there was an extra click in there. Point at which the edges meet, rather than saying the point where the edges meet at. That's poor English. That's bad English. So this is a zoom here of that little corner there. There. That's a vertice. A polyhedron, to demonstrate, has two parallel bases and the faces are rectangles. Now, if we were to open that 3D figure, cough in your shirt, since you got a looser shirt. If we were to take that polyhedron and open it up, it's called a net. Yes, somebody's coughing. You don't have to look at him. Yes. So, it's coughing. if we were to unlock that guy, for example, here is a net of a triangular pyramid. Okay, this is a net of a triangular pyramid. If I were to close this guy back up, there's supposed to be a cover here, but I have so I could change this into a square pyramid and a rectangular pyramid. But here's the net of a triangular pyramid. This is the base. See how the missing part right here? If I were to open it up, this is called a net. Okay, not like a hockey net or a volleyball net. Okay, or a soccer net. No, it is like a fishing net. Just kidding. That's what it looked like. This guy here, if I were to identify the sides, here's the base. Okay, here's that base. Here is one of the sides, one of the faces. We could say that this is that face or side right there. Okay, so if it's just like unfolding, this side here would be folded up. The underside would be folded down. Okay. Okay, let's see here. Wrong button. So then we have faces. Here we have a rectangular prism. Okay? We have a rectangular prism. How many faces does this guy have? Yeah. There are 6 faces. 6. Ooh. Yeah.
You always like to find the edges. You multiply the faces by another.
Okay. So Kelly just said that we're supposed to, or we might need to multiply the faces by something else. Let's see. Let's find out how many edges there are. I'm going to highlight as I go. As I go. We'll do highlight green. So we have 1 edge, 2 edge, 3, 4, 5, 6, 7. Count with me. 8. Okay, so it might be multiplied by 2, so let's keep that in mind for later. So we have 12 faces. 12 edges. I'm going to do it in highlighter, whatever. 12 edges. Okay, we have 12 edges. Now how about the vertices? I'm going to use red. Count with me.
1, 2, 3, 4, 5, 6, 7, 8.
Beautiful. So we have 8. We have 8 vertices, and I can do and I'm only going to do those there. That's is that the 8 vertices? Did I do the same one twice? 2, 4, 6, 8, 10. Yeah, it should be only 8, not those 2. Oh, that's why. These 2 are already taken care of. All right, let's see. So it was multiplied by 2 for the other one. Let's see if it works with this one. A triangular prism. Okay, triangular prism. So let's do the faces. I'll do so we have 1. Ooh. Sorry, I don't know why that's my first reaction whenever okay, so we have 1 on the top. Let's go 2 on the side, 3 on the other side, 4 on the back, 5 on the front. 5 faces. And the reason it's called a triangular prism, because look at number 1 and 2. Look at those faces. Okay, that's going to be its base. That's where it's identified. Because everything else is rectangles, but there's 1 triangle in there. All right, so let's talk about let's see, actually I'm going to label these the same way we just did. Would you like to get a drink, sir? Go for it. You're just as far from that drinking fountain as you are that drinking fountain, so it's either left or right. That's cold. You don't need cold water. Your body needs water. So yeah, it's better for your body. All right, edges. Let's count the edges. We're going to do this together. I'm going to do green because green means go. So edges. Count with me. Ready? That's not green though, Scott. There we go. Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh. So it didn't. Oh, there's a keyboard. It didn't quite work out. It didn't quite work out. So we have only, what was it? 9 edges. Can you read that okay? Well, you can hear me. I think it's better on YouTube. Let's see. Yeah, you can read it on YouTube, just not on the projector. So vertices. Let's do red again. Boom, 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 boom. So we vertices. Count with me.
1, 2, 3, 4, 5, 6.
Yep, just 6. Solamente 6. Six vertices. 6 vertices, yes. 5 faces. 1, 2, 3, 4, 5. 9 edges. And 6 vertices. And then we're moving on. Now we have a cube, which is a square prism. You see, excuse me. Right? You see these right here? These little tabs are for, those are the parts that if and when we make these, it just takes so much time in class. If and when we make these, that's the part that you would keep connected so we could glue it or tape it to that part. Okay?